I like that video. Thank you, Mark. I very much enjoyed your presentation. We only have half an hour, so I wanted to do a deep dive, but half an hour we're not going to dive very deep, unfortunately, but we're going to have a lot of fun anyway. And I apologize you get to hear from me twice, but we'll have fun anyway. So I wanted, as I talked about before, I talked about the different industries that are using OpenStack. So this time I wanted to start by talking about some use cases and then show you with the technology how come they can use this technology to meet those use cases. Okay? So we talked about, I gave you a list of the different industries. Let's talk about how it's being used in those industries. So the first one I want to talk about here is one of the use cases is that cloud gives them the technical agility and efficiency and gives velocity to their business, okay? And I'll give you, I'm not going to use company names here because I really don't want to, I want to try to stay somewhat generic. But this example here is focused on a media provider, okay? And the interesting concept about this media provider is they needed the agility. They discovered that the agility they needed is to push their data centers as close to their customers as they can get them. Now that's kind of counterintuitive to most of the industry today. Most industry is talking about data center consolidation, right? Let's get things as close to the center as we can. Their case is actually, they said they got to get the data as close to their customers as they can get it. Because if you think about it, if you're running media is very intensive on the network, right? So the closer you can get it to your customer, the shorter the hops and so forth. So they needed to get their data centers as close to their customers as they needed. So OpenStack gave them that capability. The second example is they needed to be able to do very rapid and cost-effective service deployment. Okay, this actually turns out to be a research center. And the research center, they've got like 60 to 80,000 cores, so it's a very large research center. And it turns out that a big chunk, and this is actually a research center here in Europe, a big chunk of their time, they're used their data center, their compute power to gather data from sensors. Okay, so they're gathering this data. Then once they've gathered this ton of data, they have to go through and quickly and rapidly reconfigure their data center so that they can munge that data, filter it down to the subset that they want. Then they turn around and turn it over to their scientists and physicists to analyze that data and perform simulations on it. So before they had cloud, they had all this uptime and downtime when they were trying to transfer from gathering to filtering to simulation. And using cloud, they were able to do that very rapidly and in a cost-effective manner. Third one example is the example of elasticity. And a use case for this one happens to be retail, okay? If you think about retail, their business goes in spikes, right? They have sales, the amount of people coming in and browsing and searching and purchasing, hopefully, goes up. And then seasonal, you got the holidays, people come and buy, and then it goes down. So they needed that elasticity to scale up very rapidly and to scale down just as rapidly and reuse that resource for other purposes. An interesting study that I read, and I'm going to have to do this by memory, so with the gray hair you can tell how short my memory is. But back in 2007, IDC did a report, Forrester did a report, and they were analyzing how long a person would look at a web page before they left and went somewhere else. And back in 2007, they found that people would wait 2 to 4 seconds before they would say, I'm tired of this, I'm going to go to somebody else. How many of you would wait 4 seconds for a web page to refresh? Nobody, right? So 2007, they found it was 2 to 4 seconds. I believe it was around 2011, we were down to 1 to 2 seconds. They refreshed the study in 2013, and they found that people were willing to wait up to 400 milliseconds. Okay? So that's why I didn't expect anybody to raise their hand, is we don't want to wait. And so retailers have figured that out. If they take too long, you're gone, right? You're going, oh, their web page must be down. I'm off to the other vendor, and I'll buy it from them. So the elasticity gives them that ability to rapidly scale up so that their response time doesn't go down. And then when it's not needed, they can scale back down and utilize those resources in other ways. Next example is the ability to design a full software environment. As Mark talked about, we're becoming a worldwide scale computer, right? Everything's getting tied together. Applications that are being developed for that scale need to be tested at that scale. How do you do that? Okay? Well, it turns out cloud is a natural way to do that. So you can reconfigure rapidly your data center so that it can be used in a way to test that software and develop your software in a full-scale environment. And then my last example here is that particularly what we're calling our IT departments, if you think about your enterprise and you think about an IT department, we're having a transformation happen, right? An IT department is becoming not just a provider of computers and help desk, they're becoming a full-fledged service provider, okay? And the interesting phenomenon here is they're not just expected to provide the compute resources like traditionally were thought of, but they're expected to provide high-quality services because your IT department is competing with other service providers. So you're in a way, in a sense, competing. But the advantage people are finding from this transformation is the IT department isn't just providing the compute services like they used to, but they're helping to align businesses. So they're beginning to foster the conversation and collaboration between the business units, okay? Helping them to understand best practices that the other businesses are doing, how they're modeling, and so forth, and they're providing that greater service, okay? So huge transformation. So those are some quick use cases. As you think about those use cases, they're very different. Okay, the technology that you need for those are actually quite different. Some of them are very storage intensive, others are very compute intensive, others require very distributed resources, others are requiring that you consolidate and try to get them into the same location. Very different use cases, but as I mentioned in my previous presentation, it's very interesting that OpenStack is able to do that. And why? So let's look at the reason why. Oh, I had one more. Okay, we'll skip that one. We'll go on. So there we go. Well, we'll skip a couple slides there just for fun. There's a lot of different components within OpenStack. In the previous slide, all I was going to point out is those components are all talking to each other. Okay. Our design principles are such that we try to separate the modules, but yet we need them to communicate. So we separated them, which is a very good thing, and we continue to do that because we realized we wanted to make it massively scalable. Remember that? Massively scalable, but easy to install. To make it scalable, we wanted to spread out those services as much as we could, but we needed them to talk together. And we could talk about each one of those components individually, but given the amount of time, we can't do that. So I wanted to talk about them in layers, okay? And so as we talk about the green stuff here is what we call infrastructure as a service, which is OpenStack. The top layer is the layer that you'll see from either a visual or graphical perspective through what we call our dashboard. This is your graphical interface, right? This is where you're going to do the drag and drop to start services and stop services and move the locations and set security parameters and so forth. So you can do that through a graphical interface, or you can do it through a programmatic interface. So the programmatic interface gets used by the other layers of cloud, like platform as a service and software as a service, and it gets used by, if you're for example, in an IT shop, it's getting used by your business processes. That's your interface into cloud, okay? The next layer down is your service interface. This interface, most of these modules are actually very new and are currently not part of the integrated release of OpenStack. But this is where we're getting the new services like database as a service and data processing or big data. Okay, so these are the services that are launching message queues for software applications, or the processes for running your big data. The next layer down is what I call the orchestration layer. I don't have a pointer, but the piece there, it says deployment, orchestration, metering, and monitoring. Orchestration is kind of the brain of compute, okay, of cloud. This is the part where we talk about in cloud automation, right? It's the orchestration piece here that's giving you the automation. Mark mentioned the metering and monitoring. This is the module that's sitting there watching for events, okay? And the orchestration piece acts on those events. So you set high water marks, you set low water marks, and you use the orchestration piece to automate and react to those events. And Mark described some of those that you get from network and so forth. The next layer is your capacity piece. This is the heart of cloud. Okay, so this is the piece that we usually talk about. So this is your compute, your storage, your networking, your identity security, your tokens, your key management, and so forth. And you'll notice on this layer, I put a virtualization layer below it. Okay, so there's a couple things here with compute. And I should talk about this actually in all the components. We're really trying to design the components to be extensible. So compute is extensible through what we call a scheduler. And one of the reasons those use cases work is you can come in and schedule resources according to the type of cloud that you're running. Okay? So my scheduling algorithm is going to be different for a storage cloud than it is for a compute-intensive cloud. Okay? So the reason those use cases work is we've built extensibility into the compute module. Same thing with storage. There's lots of options out there for storage. Okay? So we have Swift. Many people are using Ceph, and we're using Gluster and so forth. So there's a lot of extensibility available in storage as well. So the next layer down is what gives us the scalability of cloud, and this is the virtualization layer. And we talk about virtualization, we usually think about virtualization as the hypervisors, right? The ability to run on Xen or KVM or Hyper-V or whatever, or Docker or so forth. But as Mark pointed out, it's also the constructs for dealing with your network. So this is where we get into the notions of NFV and SDN and so forth. But it's also bringing in services such as firewall as a network, firewall as a service, DNS as a service, and so forth. It's also bringing in, the virtualization is bringing us the different types of storage for object storage or image storage and block storage and so forth. Okay? So that virtualization is separating the hardware for us from the software, from the cloud software, giving us that scalability that we need. Okay? Can't see faces, so I have no idea if I went or not enough. But come find me after. We'll have some great conversations. And then, of course, you've got to put that on some hardware platform, which is the gray box underneath, and we can talk about that later. But so these are the different pieces and the different layers as part of OpenStack. And now I'm going to put my vendor hat on a little bit here and say, why do you need a distro? If I can go out and get OpenStack and download this open source, why would I need a vendor? Okay? And I could put up a slide for all the 390 vendors, well, they're not all 390, but the 300 and so vendors from OpenStack, and their pictures are actually going to look a little bit different. Okay? So what happens is the vendors, and this is one from Suse Cloud, from Suse, this is their product offering. So we've picked up OpenStack. So we've picked up those integrated pieces of OpenStack. Okay? So that as the other pieces get completed and get added into the integrated release, they'll get included with Suse as they deliver their product. So the boxes in orange is OpenStack. Okay? But Suse has looked at their customers' needs and said, okay, they need additional services around that. Okay, so they've added in support to make it easy to install. Okay, And again, these are additional open source pieces. So they've added in support to make it simple to install. If you try to install OpenStack from the website, has anybody tried to do that successfully? Okay, I got a couple hands. Do you remember how many parameters you had to set? 4,700 and... Yeah, there's a whole bunch. So one of the criticisms we've had with OpenStack is it's very hard to install. You go down and build the code, do it from the website. It's very hard to install. There's thousands of parameters, and if you get some of them answer the questions differently on some of them than the others, it can be very hard to install. So Suse, recognizing its customer base, said we can make that very simple. So they're using open source software to do that with. Other required services, we needed a message queue and so forth. So they've added those in. Additional products are also needed to manage it. So they talk about Suse Manager to manage and update your workloads. Suse Studio to build those workloads. Okay, and as I mentioned earlier, we have the extensibility to add support for other database or file systems. File services. So we've added support for Ceph. Suse also supports all the different hypervisors. So again, that extensibility within OpenStack allows the vendors to choose which and what they're going to support. Suse said we're going to support them all. Again, to other areas like adapters for storage devices, adapters for networking devices. And a lot of this that they gathered is based on their 20-year history of working with open source and partnering with many of the people that are sponsors here today and making sure you work. So you can go out and grab the open source. It's just like, how many of you want to go out and grab the Linux kernel and build your own Linux distribution? It's a lot of work, okay? And when you get done, you got to go find drivers for your particular storage devices. You got to find drivers for your networking devices and figure out that they all work together. It's a lot of work. And what the distros have done is partnered with the hardware vendors, and over their 20 years experience have built this huge set of supported and certified not just hardware devices, but applications as well. So they wrap all that together, make it easy for you to consume. Okay? Oh, there was one more point here I wanted to add. In cloud, we talk about the notion of pets versus cattle. Have you guys heard that? Pets versus cattle, right? If a pet gets sick, you fix it. If a cow gets sick, you shoot it and eat it, right? So the notion in cloud is if your server gets sick, you just shoot it and start up a new one. But we've talked to a lot of businesses and found out can't really do that, okay? So Suse has added in support for high availability, recognizing that in an enterprise environment, it's not always cattle, but you have pets as well. And so in the latest release, they've added in support for that. Now, as I said, everything is open source. The OpenStack community is working on high availability, and actually Suse is participating in that. So this technology is getting folded back into OpenStack. So it's not that they're doing these things off on their own. They're participating in the community and feeding this stuff back. And you'll find that pretty much all of the vendors that are involved in OpenStack are doing the same thing. So as Mark described, all those initiatives from Cisco, they're doing the same thing. They're adding that technology back in, and OpenStack just keeps getting better and better and better. All right, so I got just a couple of minutes left. I wanted just to take a couple minutes and talk about some of the things you should think about when you're starting to think about deploying cloud, okay? And in particular, these concepts, again, are based on private cloud, but they're not really that tied to public cloud. Or excuse me, they're not really that tied to private cloud. They pretty much apply as well. So the first one is, well, we're going to see the first two. The first one is you need to align your business processes to maximize the cloud value. This is hard. It's not a technology question, okay? This is actually your business question. How does your business work? Okay? When somebody calls the help desk and says, I want to deploy a new service, what's the process they go through? I've seen the whole range from it's very paper intensive, it's very manually intensive. I've seen businesses that have full range of automation scripts, okay? And to maximize the cloud value, you've got to be able to plug cloud into your processes, okay? It gets harder if you've never defined those, and it's easier if you've somewhat automated those. And remember I talked about that top layer? You use that programmatic, those API interfaces to plug that into your business process. When you do that, all of a sudden you go from that 2-week to 4-month scale of deploying a service to minutes, right? Because now I can leverage the value of cloud, the automation that it gives me. The second point is you need to define the meaning of self-service, okay? Are you going to allow people to create services on their own or not? Okay, I can't answer that. Many businesses do. They allow their lines of business to go out and click a button and create their own service on their own. Others businesses, it scares the heck out of them just to even think about that. So you have to decide that up front. What does it mean by self-service? The third one is you need to get the workloads right. Okay, figure out the low-hanging fruit. My advice is figure out the low-hanging fruit. I've talked to some, actually, this is government use cases. The folks were working on something for a year and a half. Well, after a year and a half, I would imagine your boss is going to start saying, what are you doing? Right? But the experience I've learned is figure out the easy fruit first. Go find the easy use case. Quickly get that up and running. Pick a line of business that's got an easy one. You get them running, they're going to figure out, this is pretty cool. All of a sudden, they become your sales team and your marketing team. They're telling the other lines of business how wonderful it is that they're on your cloud, and they're advocating for you. You no longer have your boss on your tail, and you've got somebody else telling everybody else how wonderful it is, and they're now knocking on your door wanting to be on your cloud, okay? So pick the right workload. You're going to find there's workloads that are going to be very hard to convert to cloud, but there's going to be some that are very easy. So pick the easy wins first and go from there. Number 4, to bill or not to bill. Now, the answer really is to bill, but I'm not saying you actually charge, okay? This ties back to number 2, which is define the meaning of self-service. You put up self-service and you say, hey, you can have a virtual machine of a megabyte or a terabyte. Your line of business are going to go, terabyte, right? Why not? You offer it to me, I'm going to take it. Yes. So the reason you want to bill is not that you want to charge them, because your business model may not be that you actually charge money between departments. But you want them to understand what they're really using and how much they're really using. So what we've found is as people begin to understand how much they really need, they make better choices back when they're deciding what they need. Okay? So it's an education cycle here. And then the last one, if you build it, get them to come. This ties back to my discussion of low-hanging fruit. Okay? If you build it, show success with some easy wins, you'll be able to get them to come. All right, last slide here. We already talked about joining OpenStack, but I wanted to show a little slide here of Suse with Suse Studio, because I've talked to a lot of people and they're going, oh, it's really hard to get this set up and it takes a lot of time. I throw up this link here for 2 reasons. One, where's the Dutch word? You said it's free. Actually, I don't have time for the story, but I find out that's really true. I had a friend that's from Amsterdam, and the first time he told me that, I was going, no, anyway, he told me it's really true. Okay, it's free. It's an appliance, so it's very easy. Just go pull this. Just go out there with this URL. Grab the appliance and give it a try. The instructions are there. You can, in fact, even try it online. You can get pretty far just there online, clicking on it, saying test drive it. So I mainly throw this up here because I know it's a very easy way for you to go look at OpenStack and just see what it looks like, right? I'm not saying you want to go out on Suse Studio and build yourself a cloud. I'm just saying go out and check out this appliance so you can just kind of get a feel for what it looks like. Now you can go from there with Suse Studio and with the appliance, you can tailor it and do whatever you want. So it's, it's not just a one-time end deal, but it's a quick, easy way for you to just see what it is we're talking about today. So it's not just a bunch of words, but you can go put your hands on it and go, oh, I kind of see what dashboard is all about. Quick, easy way to try it out. And I believe that's it. So again, thank you for having to listen to me twice.